Okay, these notes, we're going to talk about multiplying matrices. I will tell you multiplying matrices, I'm going to give you a little bit of a warning, is not what you think it would be. It's counterintuitive, and it's a little tough or confusing, so make sure you stick with me. We're going to do 3 examples. In order to multiply matrices, this is going to be different than adding and subtracting. Adding and subtracting, we have to have the same dimensions. In order to multiply matrices, the inner dimensions must be the same. And you'll see what I mean when we look at an example. The inner dimensions have to be the same. The dimensions of the product matrix, or product matrix, by product, I just mean the answer. So the answer that you're going to get after you multiply are the outer dimensions. So this is all based on whether or not you can write the dimensions of a matrix. You have to be able to write the dimensions in order to multiply. Okay, so here's how this is going to work. Example 1, it says find the product, so we're multiplying. The first thing you're going to do is you're going to check, is it even possible to multiply? To do that, you are going to write the dimensions of both matrices. The first matrix has 3 rows and 2 columns. The second matrix has 2 rows and 4 columns. Okay, so in order to multiply, the inner dimensions have to be the same. Inner dimensions in this case are the same, so yes, it is possible. The outer numbers are our answer. So our answer is going to be a matrix that is 3 by 4. And remember, that tells us 3 rows, 4 columns. So what I find helpful is to draw out what my answer should look like. So I'm going to have 3 rows and 4 columns. So I'll have 3 rows, 4 columns. Leave yourself space because we're going to need some space to work. So 3 rows, 4 columns. Now, you should be able to tell we can't just multiply corresponding elements because our matrices are different sizes. The deal with multiplying is you always multiply every row by every column. So here's what I'm going to do. I'm going to multiply the first number by the first number. So 2 times 1 gives me 2. Then I multiply second number by second number. So 3 multiplied by -1 gives me -3, and I add them together. And then I keep going. Again, I do this row by the next column. So first number times first number. 2 times 2 gives me 4. Second number times second number. So 3 times 0 gives me 0, and I add them together. Now, same row, next column. So 2 times -2 gives me -4. Second element times second element, so 3 times 3 gives me 9, and I add them together. Okay, and then that same row, last column. 2 times 3 gives me 6. 3 times -4 gives me -12, and I would add them together. Now I do that same thing all over again, but with this second row now. So second row, first column. So -3 times 1 will give me -3. Second element times second element, so 1 times -1 is -1, and I add them together. So now that same second row, this time second column. First number times first number, so -3 times 2 is -6. 1 times 0 is 0, and I would add them together. So now that second row, third column, so -3 times -2 is +6. 1 times 3 is 3. And now our last column. -3 times 3 is -9, and 1 times -4 is -4. Last one would be this last row with all 4 columns. What I want you to do is fill in this last set of numbers and then come up with the final answer, please. So do the last set of numbers and then come up with the final answer, please. Okay, my answer is in red off to the left. How'd we do? Good? Are my numbers right? Yeah? Okay, so hopefully we can see it's kind of the same process over and over again. It's pretty tedious and it's easy to make a mistake, but once you get it down, it's just doing the same thing over and over again. Questions before we look at a few more? Okay, looking at example 2, what I want you to notice about example 2, it's the same 2 matrices from above, just in a different order. So it's the same 2 matrices, we just wrote them in a reverse order. So the question is, if I flip the matrices, can I still multiply them? Dimensions of the first matrix: 2 rows, 4 columns. Second matrix: 3 rows, 2 columns. So question 1, is it possible to multiply these? No. Numbers inside have to be the same, and they're not, so you would just write not possible. So that shows you that order matters. When you're multiplying matrices, the order is very important. You're going to have something like that in your homework. Then you'd just be done. Okay. One more, so let's go to the next page, please. Okay, can anybody tell me the dimensions of the first matrix? 2 by 3, thank you. 2 rows, 3 columns. Second one, 3 by 1. Okay, inside numbers are the same. That's good. Our answer then will be 2 by 1. Two by 1. That means we're going to have 2 rows, 1 column. So we are only going to have 2 elements. That's it. 2 rows, 1 column. I would suggest when you are doing this that you always circle the row and circle the column that you are multiplying. I would like you to do this one, please. So take 2 minutes, complete this one. Here's what I got. You all agree with me? Beautiful. So row by column, add all the elements together. Not too bad, right? Like I said, tedious, but not too bad. Okay, that's it for notes for today. Questions for me?